Hello, everyone. In this demo, we're going to build a little bit on the demo before where we talked about finding the sum of a list of positive integers. This one's only going to ask for one number from the user, and our goal is going to be to determine all the digits of that number and also track the sum of the digits as it goes along. So first thing we'll do is declare a variable for the user's input number, which will say int num. And we're also going to want a variable for the sum of the digits too. And again, keep in mind that sum should definitely be initialized to 0. Otherwise, there's going to be a garbage value left in that memory location, and you might be adding into that garbage value as you go along. This num in this case probably doesn't need an initial value because we're going to immediately ask for it from the user. So we'll give the prompt line cout, enter a positive integer. And let's do an input validation loop here too. We'll make this pretty user-proof. So while num is less than or equal to 0, the user didn't follow our directions, cout, you must enter a positive integer, enter again, and cin num. And like we've been doing in the other demos, it's a good chance to pause and build this and make sure this first loop here is working correctly. So we'll do that. Okay, so enter a positive integer. I'm not going to follow directions. I'm going to say -9. You must enter a positive integer, so -10. Let's say I didn't even read that. Enter a positive integer. Let's do 0. Nope, that's not positive, so we'll say 15. I'll finally get the point. Okay, great. So again, definitely pause and build these as you go along when you have more than one task going on in a program. It's just a good habit to be in. Okay, so now the heart of the program is going to be designing a loop that figures out each digit of num and then puts that digit into the sum variable, and at the very end displays what the sum is. So this is a nice review of using the mod operator with both mod 10 and also divide by 10. So keep in mind, if I do mod 10, that's going to give you the last digit of an integer. And if I do divide by 10, it's going to truncate / drop the last digit of an integer. For example, if I did 1, 2, 3 mod 10, it's going to give me the 3 at the end of that. And if I did 1, 2, 3 divided by 10 with integer division in C++, that's going to give me the value 12. So that will effectively drop that last digit. So our goal is going to be to design a loop that uses these two operations kind of in tandem. So what we'll say is our goal is, again, let's imagine I input 1, 2, 3. Our goal at each step is going to be to grab the last digit, put that into the sum variable, and then effectively drop that last digit for the next step. Now, this process should keep going until we hit 0. Once I've hit 0, that means I'm basically done grabbing digits from the number. Think of the very last step of the loop when you're at the number 1. 1 mod 10 would be 1. 1 divided by 10 with integer division would be 0, and that means you've effectively processed every value out of that 1, 2, 3, 1. So again, I'm not going to handle the sum part at this stage. I'm just going to see if I can design a loop that grabs every digit and then runs until basically we're done grabbing digits from that positive integer. So the loop control is going to be while num is greater than 0. It means there's still digits to be processed. What I'm going to do is declare a variable just within this loop called digit and assign that to be num mod 10. Now, to make sure that works correctly, I'm going to give this a temporary cout statement. This won't be part of the final product, but it's just good to check that this is working well as we go along. And then to update this loop, because if I don't update num, this loop might be infinite. I'm going to say num equals num divided by 10, or that shortcut operator, num divide equals 10. We'll do it that way. And again, just a reminder, that's num equals num divided by 10. And to see if that works correctly, we'll see out the value of num there too. We're eventually going to get rid of these two cout statements at the end, but it's good to see what's happening with these. That's sometimes called tracing the loop as you go through it, and it's a good strategy in these more, interesting programs that you're going to have to be working with loops. Okay, so I'm going to follow directions this time and do 1, 2, 3, 4. So what I should see is at each step, the last digit of 1, 2, 3, 4, and then it should drop that last digit and repeat. So let's see. Okay, so first step, it does grab the 4, and then when it does divide by 10, it drops the 4 and truncates to 1, 2, 3. Next step, it grabs the 3, and then the divide by 10 will truncate and drop that last digit to get 12. Then it grabs the 2, truncates to a 1, grabs the 1, and then again, when it hits that 0, that means the process is done with. I didn't put super descriptive statements on these two cout statements. That's also a pretty good thing to do sometimes, but I think it's clear that this is the digit, this is what I'm truncating. All right, so I'm going to get rid of those cout statements because we don't need them as part of the final product. And again, we're well on our way now. This loop does process all the digits correctly. So what I need to do is after I get a digit, update the sum value. So again, that variable int digit equals num mod 10. Once I've done that, I'm going to do sum plus equals that digit. So again, to remind you that sum equals sum plus digit. Take the old value of sum, put that digit in there. And at the end of this, we'll see out the sum of the digits. So cout the sum of the digits in num was the number the user entered, is sum, end out. Again, we'll do 1, 2, 3, 4 as a test case again. So enter a positive integer, 1, 2, 3, 4. So the sum of the digits in 0 is 10. So that 0 is weird, and we'll talk about that. But let's see if that actually has the sum value correctly here of 10. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So, okay, good. The digits were added correctly, but you want to think about why it's displaying 0 here instead of the original 1, 2, 3, 4 that I entered up here. And the reason is this loop is modifying that value of num that the user entered. So a workaround for this is you can introduce what's sometimes called a holding place for that original number if you want to display it again. You could definitely display this part of the output before the loop if you wanted, but I'm going to introduce what's called a holding place for that original num, that value of num. And then instead of displaying num here, I'll display hold. And again, that's purely just because this loop is modifying num. If I want to reference back the original value, I'll put it in this little holding place, this variable that's purely just to hold on to that value. And we'll see if this, again, is a nicer output statement at the end that actually gives us back the 1, 2, 3, 4 from that test case. Okay, great. Enter a positive integer. Sum of the digits in 1, 2, 3, 4 is 10. So this is a very good program. You want to take some time to understand every step in it. Working with digits is a pretty common thing in a lot of algorithms, or just even checking for divisibility. This mod 10 and divide by 10 are very commonly used. I know when teaching APCS, there's so many questions that have shown up on AP tests that involve those. It's just such a common coding task with loops. So again, hopefully this demo was helpful, and definitely take some time to make sure you try this demo on your own and even modify it in a little bit.